Hey guys, and welcome to Functional Print Friday. And welcome back to my basement shop. So for the past couple of weeks, we have been working on designing a fume extraction system that will be compatible with the back of the H2 series printers. And we've tied into the radon mitigation system down here in my basement to enable that. So if you want to see how we did that and how we did that in a safe way to not impact the ability of that radon mitigation system to still function correctly, and also how we designed the blast gates that control the flow of air in this system, I will link to the previous couple of weeks' videos where that work was done, and you can check that out for yourself. And where we left off last week is I teased this piece very quickly. This is sort of my V1 design that's actually going to interface with the back of the H2 series machine for that fume extraction. But I said this is not going to work for numerous reasons, so I want to show you how I got to this point, and then also talk about what's wrong with this and how we're going to fix it. But before we do that, there is one other item of housekeeping that we need to take care of. And that's the purge bins, or really the lack of purge bins on the back of my machines. And it's not because I don't have purge bins or run purge bins on these machines. You guys probably remember, a month or so ago when I designed these retainers for what I called my favorite purge bin for the back of these machines. But you guys pointed out several issues with the purge bin that I was using. And I've actually redesigned it, or I should say I've redesigned the redesign from the author. But I don't want you guys to see it until I had the opportunity to catch up with the original author of that design and get his permission to be able to share my updated design in a print profile. So let's take a look at that. A lot of people commented that when this was installed, it was blocking these vents on the back of the machine. And you're 100% right. And several of you actually pointed out that the author had shared a updated design of this that had a knockout on the back from basically like this point down that no longer blocked these holes. So I grabbed the author's updated design and printed one out, and as you can see, that's no longer going to block those holes on the back, even when this is pressed all the way into place, so that's good. But unfortunately, it doesn't print very cleanly. We've now picked up a pretty big overhang here on the back with that cutout section, and it prints really poorly where it actually interfaces with the back of the machine, both inside and out. So I had some ideas on how to fix this, and I'm at the point now where I'm ready to share it with you guys. So let me show you that. So here's that updated design, and this is by NYX_NK on MakerWorld, and I will put a link to this design down in the description of this video. Basically, the only difference between this and their original design, as far as I can tell, is this cutout here on the back to allow airflow in and out of those small vent holes on the back of the H2 series machines. So this used to just drop straight down, which means now we have a little bit reduced capacity in here, which is not necessarily the end of the world. If you're printing multicolor, you're probably going to notice that difference. I would say that's, I don't know, maybe a 20% loss in capacity. The bigger issue though is, now maybe this prints fine in PLA. I don't know. I did print the original one, the original design, the first one I printed that one in PLA. I noticed the author lists PLA in their profile for this as well. PLA, I can tell you, will soften up here when you're printing high temperature materials on an H2 series machine. I had no issues until I think I printed maybe the nylon print for the Corolla part that we did a while back, and mine softened and deformed up here in the top. I reprinted it in PETG HF, and when I went to reprint their new design in PETG HF, well, you guys saw the issue. We had a lot of, not very clean printing up here where this overhang starts, where the curve is, and especially up here with this little kind of thin lip. Like, it really comes to a point here, and that's difficult for any machine to print, basically coming to a sharp point like that. But when it's on an overhang, especially with PETG or another material that is going to handle the higher temps a bit better, it's really, really difficult to print that. So let me show you what changes I made to get this to print a bit cleaner. And here is my updated design based, again, on the author's updated design. And seeing them here in the same three-dimensional design space, probably the first thing that stands out is how much longer mine is. I decided to increase the length to get back that additional volume that we lost here with the updated design with the cutout to clear the vents. And the reality is, even with my longer design, we're still way short of actually contacting the desk or table surface, wherever your printer is sitting on. This could be even longer in theory, but this brings us to slightly higher capacity, I think, than the original design of this. The other thing I did was I kicked it off at an angle. It is going to print a lot cleaner at this angle because we've split the difference of all of these overhangs. You can see we had really no overhang in the front here, but we had quite a bit of overhang here in the back and on the pieces that fit up inside the machine as well. By kicking it off at an angle like this, we sort of split the difference now on these overhangs, giving especially the overhang here in the back a much greater chance of printing cleanly. The other thing I changed is the geometry around the lip here, where the bin actually meets up against the bottom of the chute on the H2 series printer. I mentioned before that this one comes to this really, really thin point that's also at an overhang, making it really difficult to print. Now, we solved some of that by tipping this back, but I also changed the geometry to have this beefier section that sits up against the back of the printer. And you can see this still comes to a fairly sharp point, not as sharp as the author's updated design, but because we have this tip back, this also prints straight up and down. So it's almost like we're kind of just, printing a triangle here, and when we get to the top, this will be a single extrusion, so it should still print pretty cleanly. I've also got mine up a little higher than the author's updated design. I'm not sure why he's got it down so low. My assumption is, having only, probably one machine to test against, there's going to be some variability between printers. So, the desire is that, on anybody's printer that they put this on, you don't want this edge to be sitting up higher than the bottom of the chute, otherwise stuff is going to get caught there. But I've got two different H2 series machines, an H2D and an H2S, both produced, several months apart. So I'm confident with the fitment of this. I'm at least, I think, 1.5 millimeters or something below the lip on mine, on both of my machines. So I'm confident that this is going to fit. And I adjusted the geometry of the little breakaway tabs here as well when I adjusted the geometry of this. One last thing that I did was I noticed that, see this top section here, let's take a look at the original one first. This pretty much lines up, this top face pretty much lines up with the top of the inside of the chute. And the inside of that chute is curved at the top. So this presses really tightly against it, and it actually kind of deforms it a little bit, not having any relief there. I adjusted mine just to have a little bit of a relief up here at the top. And I used a bevel just so that there's, again, a little bit of relief so that it fits against that surface up at the top of the chute that is actually slightly curved. And this one slides in a lot better. It still stays in place just fine. And then, I actually forgot that I even did that. I put a little bevel here. So the author had these just as a flat stop. I put a little bevel on mine, and then I shortened these supports to align with the bevel. It's just, you could clean these up with sandpaper, not a big deal, but it was already in here, so I figured may as well update that. So there you go. Now you can see the updates that I made to that bin. I can stop taking them off the back of my printer every time I'm shooting video down there, and I will link to, again, the author's design on MakerWorld, and there will be a print profile in there. You'll see my little logo, my little FPF logo for that print profile. So if you want to download this one and print this one, you can do that right from the author's original design page. And I've since gone ahead and printed out two of these in my updated design. And in fact, actually both of these have been in use for the past couple of weeks on my H2 series machines down here in the basement shop. And here is the print of the author's updated design. And if we just compare those, you can see it is night and day, because we've effectively reduced the angle of that overhang by printing this guy at an angle like that. And if we look at it from the inside, you can see same thing. The geometry there is now printed 100% clean, and there's no sanding or anything on this. This is right off the printer. Same thing for this one. I probably could have, cleaned that up a little bit by sanding some of it. But again, it makes a huge difference to really think about the orientation of your part. And even if it seems natural to print it straight up and down, like you would a purge bin like this, ask yourself, can you potentially print it at an angle? And then furthermore, I could have left the bottom of this flat. We could have had support material there, but there's really no reason not to just print that at an angle. Now, I do want to point out, I did notice there are several makes of the author's updated design where it looks like it printed cleanly. And I think what's happening is, I think people are printing it with PLA. PLA will tolerate a little bit more overhang, at least that's been my experience. So this might print perfectly cleanly in PLA. The problem is, I actually printed the author's original design in PLA. And you can see what happened here. That heated up enough that it warped pretty badly right there, and the whole top is warped as well. I don't know if the camera's picking that up. It's sort of bowed outward there. and it's pushed inward here as well. Now some of that is because it didn't actually quite fit at the top of that hard angle, so I think there was a constant pressure on it. But this one down here, you can see that is just from the heat billowing out of this guy from the chamber and printing a higher temperature material. So yeah, I mean, you might get away with this in PLA, but I think we have a much better option here in this printed in PETG-HF with the additional capacity as well. So compared to the original design, this one might actually even have a greater capacity than the original design. And let's go put these back in the printers. You see how they fit. And with these back on the machines now, you can see that we are nowhere near the maximum length that we could make this. We're not blocking those vents on the back. And I actually kind of like the look of the angled bottom. Again, that was not an aesthetic design choice. That was just to enable us to print the whole bin at an angle without having extra supports at the bottom. But I don't know, I kind of like the angle of the bottom. I think it looks neat on there. And here's what the transition looks like from the bottom of the Purge chute into the bin. You can see we've got a little bit of room to spare there. Fits just fine. And here's the same view on the back of my H2S. Looks pretty much identical to me, but in either case you can see that there is no gap between the Purge bin itself and the Purge chute sits just above the height of where it drops into the bin. I also made another set of these Jet Blast slats with the top vent for the H2S, so let's put those on quick too. All right, I think that looks good. And more importantly, we now actually have our little custom vent slat on the top of each one of these machines, which we're going to need for the next step. So to that point, I think it's time for me to talk about how I got to this design and what's wrong with it. So here's where I started with the design for the fume extraction pickup for the back of the H2 series machine. And honestly, this is where I should have stopped. I should have stopped before I even extruded this vertical section here. I should have stopped just basically with the design of this bottom piece here to see how it actually fits up against the back of the machine. I mean, you know, I think the location of the magnet's probably not a big deal. But the location of these bores here to press in pins to key this to the back of the machine, yeah, I shouldn't have just assumed I was going to nail that on the first try. But I did for whatever reason, and I kept going. I sort of imagined, okay, as a next step, what we want to do. And you can see I angled this face here a little bit, and then I added the geometry to it for our 4-inch flexible pickup hose. And I also kind of thought through, all right, well, so if the slats, what you can't see here is those slats are actually pointing like in this direction. So when the air is exhausted from them, it kind of has to make a U-turn, right? It's not going to just come out of these and go directly into this. That air is going to have to sort of swirl and make a U-turn and go up. And for the bottommost slat, I thought, well, you know, it'd probably be nice to have just a little thin section here that seals against the back of the machine, and then a curve that sort of starts to direct that air to go up in the other direction and enter into the 4-inch flex. So obviously I'm not going to print this boxy design. That's, you know, just kind of a, you know, starting point for brainstorming that. So this is where I ended up kind of rounding all that off. Now, you know, I'm way deep into messing with this design a lot further than I should be, not even knowing if this face is actually going to fit against the back of the printer. But this is what happens when, you know, I don't know about you guys, but when I'm designing something, I'm designing it in my head first. And then once I kind of feel like I have the shape of it or the overall design of it in my mind, I really want to get it out into CAD. I want to kind of see it, confirm it, and move on to the next step. And that was sort of my drive to, you know, sort of continuing along with the design of this, even though I didn't actually know if any of this was going to fit. So now you can see that, you know, we still have that curve here to start redirecting that air, but I've added a nice curve here as well on the inside so that all of that air can now sort of hopefully cleanly come down this way. At least the air from that bottom slat is going to hit this curve here and then sort of change direction gently up to our intake hole up here for our 4-inch flex. And since I got this far, I figured, well, I may as well just print the whole thing out and see what fits, what doesn't, what I like, what I don't like, And that led me right into my next problem of how the heck do I orient this thing to print it? Because there is a lot of overhangs here, regardless of what way you position this. And the overhangs that I'm most worried about are these curved surfaces in here, because I want this to be as smooth as possible. I want that air to be able to make that U-turn, curve, and go out of our outlet here as cleanly as possible. So my first thought is, well, we could print it on this face down here, and that wouldn't be too bad. We'd get fairly clean geometry for here and here. Our geometry on the intake would be rough. We'd have a whole ton of tree supports kind of coming from the bed down here up into here trying to support this. And we sort of have that same issue of having a bunch of a not very clean print where we're trying to get that air to cleanly flow into this, call it, I guess, outlet, inlet, depending on your perspective of the airflow. So I thought, okay, well, I guess I could print on this edge here and just have supports for this section here. That wouldn't be too bad. It might be ugly, but it's not going to affect our airflow. But then we have to support, say 30% of these curved sections here. And that could be done. We could have supports coming from now the bed over here up to here, but it's still not going to be as clean as it could be. Yeah, I guess we could sand the inside and we're not going to see that. And we'd have nice clean geometry on the majority of the outside, but it didn't seem like the best option either. So what I ultimately decided was, well, I could print the whole thing at an angle, much like I had done for that purge bin. And I settled on this angle thinking that that kind of split the difference for what was going to be difficult to print. And I was most focused on getting clean geometry on the inside here. I figured, well, it's a little steep there, but with support, it'll probably be okay. This should print really cleanly, these inside edges. And I just put supports right on here and figured we could break these away. And I think I sized these at 1 millimeter, if I recall. And I did that because if we don't do that, our contact edge to the plate is just this tiny little thin section right here. And we could turn a raft on, we could turn a brim on, but at the end of the day, there's still not a lot of contact area there, even to say the raft or to the brim. And my guess is it's a fairly big part. As we get up to the top of this guy is going to be moving around. And even if it doesn't break off the bed and the print finishes, we're not going to have very clean geometry up here because that print's going to have the ability to move a little bit. So it's going to look like there's little tiny layer shifts in the print. So I thought supports that we can just break off of this that are integrated into it are probably the best bet. So let's go back to the actual printed part for this V1 design, and I'll show you why, for all kinds of reasons, this wasn't going to work. So the number one reason why this V1 print did not work out, I already alluded to a couple of different times, my bores for these pins were in the wrong place. And it was always my intent to press these dowel pins into these holes to align this, but obviously the holes have to be in the right place, otherwise it's not going to go on there. And it wasn't off by that much, but I mean, these are pretty small. So even if it's off by just a tiny bit, it's really not going to work out so great. On top of that, I did not think about how hard it was going to be to press these dowel pins in, especially to fairly tight fitting holes, given the odd shape of this guy. Like there's no good way to press down, for example, on these. It just wants to tip. And you can see this one's missing altogether because it went all sideways when I was trying to press it into place because this moved and now it just falls out of that hole. And this one's crooked. Actually, I think they're all crooked to varying degrees. So that was frustrating because I wasn't even really sure how far I was off, given the fact that the end of these are all slightly at a different angle anyway. Also messed up one of the bores for the magnets, pressing these guys in for the same reason. And that was actually just me being, kind of rushing with this since this wasn't going to be the final design anyway. I think if I slow down and I make sure that I'm holding this the right way, we should be able to press the magnets in without issue. But that brings up another point. As it turns out, even with, let's see, 1, 2, 3, 4, 5, 6, 7, 8 of these magnets in here, that's really not enough. It does stay on there with the hose attached, but just barely. Like, it'll stay on there, but then you just barely bump it and it will fall off. We need a little bit more magnetic force to keep this guy locked into place. And that's sort of the purpose of the pins. What I was thinking is that, if this gets knocked from the side, it doesn't have to just overcome the shear force of the magnets holding on. These pins are going to keep it located, but yeah, it's just not enough. So I think we can increase the size or increase the depth of the bore for these and just stack 2 magnets in each hole. I don't know that we're going to fit 2 down there in that little guy, but we can definitely, I think, get 2 in all of these, even without increasing the depth of our overall part here at the lip. Lastly, well, actually not lastly, there's 2 more things here. So even without this going onto the back of the machine, just holding this in my hand, I can see we have way too many holes in the back. My thought with having holes in the back of this was that if I leave this on the back of the printer, and even if the hose is completely blocked, there's still an exit for air to come out of this if I do turn the vent fan on the printer, and vice versa. If I do have suction on here and there's nothing being able to be drawn through the printer, or only that little bit through the top slat, we can still draw air in through the back of this, but that's just way too much. We'd probably do with about half that many, or maybe even less. And you can see printing this at an angle, it's not bad. It really should be cleaner inside there. And actually even there, that overhang's not great either. But this one, you can see we suffered down there. Now, that's the bottom of this. I guess I really shouldn't complain about that, but yeah, it doesn't look great, and I'd like to fix that if we can. And I don't think that's an anomaly of this print. I think it's just us really pushing the overhang on that part. So, all right, I've got some work to do on this. I'm gonna work on that, and I'll bring you guys back. All right, well, it took 4 tries, but I am now confident in the position of where these bores need to be to align the pins to the back of the printer. And again, this is where I should have started. This should have been, version 1, 2, 3, and 4. And then, once I had that down, actually go and try and design the rest of the box. But, live and learn. So, all right, I've got some more changes to make on the rest of the design of this, and I'm bringing you guys back. And here is my updated design space with what I hope includes our final design for this. And first thing I'll point out here is the template that I reprinted numerous times until I got the perfect alignment on those pins. So here's, again, what I hope is our final design for this, and it's not that terribly different from our V1. The first thing that I will point out is you can see, it's actually a little bit tough to see. I guess you can kind of see it there. I leaned this guy over 5 more degrees. I think that is going to clean up the challenges that we had with the overhang here, and also give us a little bit better geometry here on our edge. Yeah, it's still going to need supports, but it shouldn't be so bad on the inside of that pickup like the last one. I thinned out the actual contact point for the supports down to 0.5 millimeter, or basically, one line width. I might be pushing it a little bit, but the contact point is so long in length, I think we'll be okay. And I adjusted the design of these a little bit as well, since when I tipped this back, these guys were now, no longer level with the bottom. So I cleaned that up. And we now have 3 bores for these pins. These are not going to press in any longer. I actually found another solution for these that I think you guys are going to like, that we'll be able to actually insert from the back rather than trying to press those in and just hope that they stay in place. And we'll actually have some adjustability as well. You guys will see once this gets printed out. The only other difference is, increasing the depth of these holes to support 2 magnets instead of 1. The only place we couldn't do that is down here. We just simply don't have enough room because we have this curved geometry down here, and this is real thin, just where, again, we're trying to redirect that air that's sort of going the wrong direction coming out of that last slat on the back of the printer. And the last thing I'll mention back around this side is you can see we have significantly reduced the number of penetrations through the back of this part. Seeing this in CAD, I felt like we were going to need this many, and then actually having it printed out and realizing just how open the back is, yeah, that's too many. All right, I'm going to slice this one up, hit print, and I'll bring you guys back. All right, our updated print is complete, and this is straight off the printer. I've done absolutely nothing to this. And I gotta say, it looks pretty good. I mean, we've got the typical PETG sort of fuzzies, like the little very, very fine, like sort of micro hairs. And yes, I dried the filament. This is just pretty typical with PETG, especially if you have a complex print like this. But you can see, I mean, looks pretty clean through those vent holes in the back. And actually, let me go grab the original one. Let's compare. Yeah, so if we look, here is our V1 print, and you can see the surface finish that we got on the bottom. And take a look at this one. It looks like that extra 5 degrees was the difference between a clean surface and a not clean surface. And for the inside, yeah, that definitely looks better too. Like on this one, I'm looking like, especially like down here and even up here, you can see. If we look at this one, I mean, yeah, we still have a little bit of mess kind of down here at the very bottom, but overall, those surfaces are a lot cleaner. And these are the 1/2 millimeter width for our break-off supports. Let's see if they actually break off. These did not. These I had to cut off with a utility knife. Oh yeah. Well, it bent over real easy. I probably still score that with a utility knife to pull it off. So yeah, let me get this cleaned up. So longtime subscribers to the channel have seen this guy before. That is my hot air rework station, and that's actually the second one of these that I purchased. I bought this one out here in the shop just for cleaning up 3D prints because it's so darn good at that. You can just go around the print quickly and get rid of all those little fuzzies on the print. Now, some folks will say you can do that with a torch as well, and that's true, you can, but you risk overheating your part. You can set this at just the right temperature and it will maintain that. But also, if you use a torch, sometimes you can get like black carbon on your lighter colored prints as well. And one nice thing about this, because we can fine tune the temperature, notice I got most of the little wispies off of this. There's still a couple in places, but got most of them. But notice here we still have marks on the print where we messed up the polymer chains in the plastic when we trimmed that and when we used the deburring tool. And I'll put a link to that deburring tool in the description as well. Hopefully you guys are all using one of those already. Talking about this guy right here. But with our hot air rework station, you see all these areas here that are light colored on the print? If we take this and we hover over those just a little bit longer, again, not too long, we don't want to completely soften the material, but they will basically disappear as we essentially repair the polymer chains in this print. It looks almost like we're spray painting it black. So if you have marks like that on your prints, or sometimes even with, this was printed at an angle, but I've pulled PETG prints off the bed, and just from the stress of pulling them off the bed, they'll be all discolored on the bottom. Same thing, the hot air rework station, it's almost like you're just spray painting it back to the original color that it was. A little bit at the top there as well. All right, well, you guys have seen me press magnets into parts in the arbor press probably 20 times at this point, so I'm not going to show you that, but I do want to show you what I came up with for the pins. Remember, we made these through bores on the new design, because I said I had an idea for those rather than just pressed in dowel pins. So I found these guys on... You guys hear that? I think there's a cricket. Sounds like he's in there somewhere. And we're trying to make a video. Can you chill for like maybe another 10 minutes, please? No? All right. All right, so I found these guys. I'm not entirely sure what their intended application is, but I think they're going to be perfect for what we want to do. They are a smooth pin on this side and then threaded on this side. And the threaded section is a little bit bigger, so I actually made the bores in here larger at this end and smaller at this end. So these should be like a real tight fit on this side, if they even go in at all. Yeah, they do. That's perfect. So that is like a, I mean, it's, you know, I can push it in with my fingers. I don't need to press it in, but that's perfect. That's like a sliding fit on this side. So we're actually going to put it in from this side and then thread it in, and we can kind of control not only how far they stick out, but they should be perfectly aligned with those bores because, you know, we're not pressing it. There's no chance of it getting like out of alignment. Let's see, I'm going to guess 1.5. Yes, 1.5. All right, now I'm not sure how far we want these sticking out. Go with there, Abbott, just below the surface. We put the other 3 in. This is actually TPU. We made this in a previous video as well, in case you missed it. All right, those are now all in. I'm not sure if that's how much I want sticking out. I guess we'll find out, but tell you what, they look perfectly straight, which I think is the most important thing versus version 1 where they were kind of all over the place. So, all right, I'm gonna get the magnets in. I'll meet you back down by the printer. So I guess one thing I hadn't considered is this is printed in a completely different orientation as the test pieces that I did. Those were printed just thin, face down on the bed. This is printed in a completely different orientation. So I guess if this shrunk or deformed in any way differently than our test pieces, still might not fit. Hope it does. It's a little tough to align on there because you can't really see what you're doing. You know, so the holes are actually to the side, so it probably makes sense to kind of look at it from the side, key one side in. Yeah, that's the way to do it. That went right on like that. Yeah, for sure. So if you do make one of these for yourself, hopefully the back of your machine is accessible. One thing I will say is the H2 series machines, you really do want to be able to get to the back of the machine just because all of the different routing for the PTFE tubes and everything, especially having to switch the lines around for TPU, it's really nice to have the back of the machine accessible. Not such a big deal on the P1 series or the X1 series or their bed slingers, but the H2 series, you really do want accessibility to the back of the machine. So yeah, if you're just kind of reaching around the back trying to line this guy up, that might, of course, it went right on that time. Okay, all right, so maybe it's not that hard. But yeah, I still think it's easier sort of eyeing the side here and then just tipping it on like that. You know, before we even try and attach the hose, let's turn the fan all the way up and just see how much air is coming out. Oh, wow. All right, I think it's deceiving because the air is a completely different shape coming out of the top of this than it is out of the slats, because it actually feels like there's more air flowing out of here than there is underneath the slats, but that doesn't make any sense. It's probably just, again, the shape of it. But I do think that we're not reducing the amount of airflow by, you know, causing it to sort of make a U-turn along these curved surfaces in here. So I think that's working out well. So, oh, another thing I did change with this one that I forgot to mention is I reduced the size at the top here a little bit. I made this more tapered, so it should be easier to get the hose on here than the coupler parts that we had from a couple of weeks ago that I sort of stole this geometry from. They were really tight getting the hose on. It should be easier to get the hose on this. Let me grab the hose. All right, moment of truth. Oh yeah, that's night and day. It's way easier to get on there, and it still tightens up as we get towards the bottom. In fact, it actually tightens up enough. It's not going to come off there on its own. I don't think we need a clamp. All right, let's try this with the hose attached now. Yeah, it's not coming off. Magnets are definitely strong enough to keep that in place. Let me turn the vent on. So even with our custom intake on the back here, the hose attached and no air able to flow through the hose because our blast gate above here is still totally closed, it actually still feels like there's the same amount of air flowing now out through our holes here in the back of the intake as we had out of the top or out of the slats at the bottom. I think that fan in the H2 series machine is just super strong. I don't know what it would take to actually reduce the airflow, but it's moving a lot of air regardless. I think it runs at about maybe 20% for PLA prints, I'm going to go put it at 20% instead of 100% and see how much air we still have flowing out of the back here. Okay, at 20%, I can definitely still feel the air coming out of the back, but it's not very much. I don't think that's going to be much to overcome by actually opening up our blast gate a little bit so that instead of the air coming out of the vents at the back, it's actually going in the flex tube. All right, I've been tweaking the blast gate up here a little bit at a time and then feeling the difference back here at the vent. And I think we're at the point where I don't feel air getting sucked in and I don't feel air blowing out. So I think we're probably like pretty much just the right point where we're sucking hopefully a little bit of air through the printer itself. Okay, I think the next step is actually going and finding my digital manometer again and figuring out how we can route the hose into the printer. I think we're probably going to do that through the Purge chute itself. And then we can measure the actual negative pressure inside the machine, tweak this to just the right amount, and maybe we can even pull this portable smoke machine out again as well and just see what the airflow looks like inside the printer. So let me fool with that. I'll bring you guys back. All right, guys, it's a couple of hours later. I've been messing around with the digital manometer and a bunch of different settings on the printer and looking at different filament settings for what speed it runs the fan at, and I'm kind of spinning my wheels. Let me explain. So what I thought I was going to do was use this guy along with a piece of tubing up into the inside of the machine through the purge bin, measured the negative pressure inside the printer as I tweaked the position of the blast gate up there, and then just figure out some settings essentially for the position of the blast gate to be in for printing PLA, PETG, and other filaments depending on the fan speed. And then, I would repeat again with the fans closed and the chamber heater on. Well, here's the thing. First of all, the negative pressure itself in my radon mitigation system varies a little bit, probably depending on what the humidity of the air is that's being sucked out from underneath my slab. Also, if I'm running any of the other intakes to that vent system, like this one for my soldering station or for the laser cutter around the corner over there. And then on top of that, different filaments have slight tweaks to the amount of fan speed that comes out of the back. There's too many variables. I stopped and I took a step back and I thought about what problem am I trying to solve, because I was way too stuck on what I thought the solution was going to be. And it's not this guy. So what is the actual problem that we're trying to solve right now? Well, we don't want to draw any more air through here than we need to. If we're drawing too much air through here, we're going to be unnecessarily drawing extra air through the printer itself, which is probably going to cause problems with even PLA or PETG, definitely going to cause problems with the heated chamber on and us drawing lots of extra air through here. Now, how I thought we were going to do that was by measuring the varying negative pressure inside the machine, and again, just kind of coming up with some presets for my blast gate. But that's going to be different for every single install. Like for me, it's adjusting the blast gate. That's how I control how much suction I have at this tube. For you, that might be adjusting a fan speed. It might be opening and closing a ball valve. So for example, right now, I have the exhaust in the printer set at 20%. So I need to somehow figure out how much suction I need in the hose here to effectively draw up that air that's coming out of our slats in the back without creating additional negative pressure inside the machine, or the bare minimum additional amount of negative pressure inside the printer. So we can put away our expensive toy and instead use the right tool, which is this tiny piece of paper towel. Yep, that's all we need, is a simple little piece of paper towel. And the great news is, I bet everybody watching this video has a roll of paper towel somewhere. And if you don't, how about a roll of toilet paper? Slip of paper? I mean, pretty much anything about this size that is light enough will work just fine. Now, all we need to do is just put this right on the back of our little intake box here, and you can see the air getting sucked into our intake box is pulling this in place. And now, I'm going to put you guys in the tripod. I can just reach up and I can close the blast gate until our paper towel falls off. And then I can tweak the blast gate until I'm right at the point where if I close it, it falls off. If I open it just a little bit more, it stays in place. And that's it. It's balanced. Now if I take this away, I can feel just a very, very gentle amount of air being drawn in here. But more importantly, we're sucking up all of that air that's coming out of the back of the printer without creating any additional negative pressure inside the printer. And here's the thing, this is what the setting is when the fan is at 20% on the printer. Well, it's not always going to be at 20%. For some filaments, it might be at 10%, 30%, or maybe it's closed. And as a demonstration of that, so if this is where we're at for 20%, I'm going to go set the fan at 30%. What do you think is going to happen? Yeah, as soon as that fan ramped up to 30%, this guy dropped off. And you can see now we're blowing air out of the back of this. We do not have enough suction to overcome the air that is exiting out of the back of the printer. But if I reach up, open up my blast gate just a little bit more, and I barely moved it. I moved it probably about 2 millimeters at the blast gate. Now we are right there. Could maybe close it a little bit more. You'll notice the edges of the paper towel or your slip of paper, whatever you're using, they'll kind of start to flutter. Yeah, like right there, that's fluttering. I probably don't want to open it up any more than that. We are pretty much right at the sweet spot. Let's go put it at 40%. Yeah, same thing. As soon as we went to 40%, we're now not generating enough suction again. So I can just reach up, can open up my blast gate. Wow, I barely moved at that time, like 0.5 millimeter maybe, but that's enough. That's all we needed from 30 to 40% was just a tiny bit more at the blast gate. We turn the fan completely off on the printer. All right, so now the fan is completely off. Yeah, look at that. Now we have way too much suction, but I can tweak it again. I'm just going to close it. Yeah, that's like pretty much right on. And the blast gate is barely open. Barely open at all. So we're now generating just a tiny bit of negative pressure in our pickup box here in the back, and also drawing a tiny bit of air through our top slat here, so that any fumes generated inside the machine are getting sucked up in here instead of either coming out of the purge chute or just escaping elsewhere on the printer. So I can already hear you guys down in the comments, and in fact several people commented last week, which you're probably thinking right now is, if we have the chamber heater on, aren't we going to suck all the heat out of the chamber? And I don't think we will. Because if we're generating just the tiniest bit of negative pressure, again, based on our paper towel trick, we're not really going to be pulling that much air through the printer, just a tiny bit. So I do expect the chamber heater is probably going to work, I don't know, maybe a tiny bit harder, but I don't think by much. But I thought of a way that we can measure that. So my Fluke 289 multimeter has a record function on it, and we can actually view trend data over time. So if I hook up an AC current clamp to this, and this translates 1 milliamp to amp. So when the display shows 1 milliamp up here, that's equal to 1 amp of current draw through the clamp. So here's what I'm thinking. We'll set this up, I'll set it to record, and then I'll turn the chamber heater on. We'll wait for it to stabilize. Maybe I'll let it run for like an hour. And then after that 1 hour's up, I'll hook up my suction box to the back. I'll adjust it, again with a little paper towel trick, and we'll let it run for another hour or so, and we'll just see what it looks like. Are we going to be drawing a bunch more current when we're sucking air out of the back of the machine? I anticipate it's going to be a small difference, but I don't think it's going to be much. But let's find out, because maybe I'm wrong. Maybe we're going to see that we're actually drawing twice as much power trying to keep that chamber hot. Maybe the printer won't even be able to keep up. I don't know. Let's find out. All right, I've got the data. And yes, our friend Mr. Cricket is still performing his solo. Tried to find him again. Can't figure out exactly where he is, so I guess he's just going to be joining us tonight. So if I hit trend here, it's going to graph all of this data for us. And you can see, much as we'd expect, when the bed first starts heating, it goes all the way up to 6 amps and starts to ramp down pretty quickly. And it actually takes a full, roughly, well, we started recording a little bit before I started the chamber heating, but almost 30 minutes for that chamber to get up to 60 degrees. Call it, what's that, maybe 25 minutes? And then this is where the temperature stabilized. You can see for this period of time here, the utilization pretty much stayed the same. Now this mess here is where I came down and added my intake onto the back and spent some time, actually quite a while. You can see there probably about 10-15 minutes getting it balanced, and I'll explain why it took that long in a little bit here. But then you notice something really weird. It starts using less power. And we can zoom in on this and get a closer look at that and just confirm that that is not some sort of weird anomaly. So you can see this is pretty much where we were steady state with the chamber. It did decrease there for a short period of time. Maybe that was like sort of full heat soak, and then it kind of went down a little bit and then cooled off and then went back to stabilizing. This is while I was down there messing with it. I never changed the set point from 60 degrees, but you can see we started to fluctuate quite a bit. And then once I got it set, we're definitely using less power. I can scroll over here. Now what this is showing us is the average power consumption during the sample time. So, if we had like a really long run from an oscilloscope, that would probably be better. But, you can see we're definitely utilizing less power, keeping the chamber hot with fume extraction. How is that possible? Let's go back down to the printer. So what is going on? How on earth did we end up with that result? Because it makes no sense, right? Well, I have a theory. So I didn't record any video while I was conducting the test, partly because the circulation fan for the chamber heater in the H2 series machine is actually quite loud. But on top of that, there was a bunch of noise above my basement shop that would have been really distracting. But when I came down to put my box on the back and balance the air with the little paper towel trick, what I noticed was there was an enormous amount of air. Now this is before I attached the box, like when I came down in the middle of the test. This whole area of the back of the printer, like this area sort of in a U shape here, was really quite hot. The back of the printer, the purge bin at the back, even my little knob here, was quite warm, almost the temperature of the heated chamber itself. And if you put your hand there, you could actually feel quite a lot of hot air billowing out of the purge chute area on this machine. I'm sure Bamboo has done a good job with circulating air through that activated charcoal filter or whatever the setup is, but here's the thing, I don't know how valuable that really is when you're losing that much air out of the back of the printer. Like, it is not a small amount. I wish there was some way that I could show you guys how much air was actually coming out of the back of this printer. Furthermore, it actually made it a little bit tricky to balance the amount of suction in the hose here, because what happens is, and maybe when Bamboo set this up and tested it, they just didn't run the test long enough, because remember, this guy had been running for about an hour when I came down to add this box to the back. But what I think happens, once everything reaches temperature, it develops a draft out of here, where cool air is being drawn in from anywhere that it can. Because the chamber itself isn't actually sealed, right? There's plenty of areas for air to get in there. And once that happens, and you have cool air drawing in from all over the place, and a singular exit point, or a big gaping hole essentially, since that goes up right into the inside of the printer, that kind of ends up as a chimney. Even though it's not at the very top of the printer, it doesn't matter. A draft develops, and you have all that warm air escaping out of the back of the printer, as much as can get in elsewhere on the printer. And in fact, when I connected this up and I put the paper towel on here, I had to keep cranking the suction up and up and up until I overcame the draft out of the back of the printer. Now, once I overcame that and this area started to cool here, I could actually then back off on the suction a bit, which is why we had that sort of the graph all over the place at first. And then once I had it balanced, I let it run for at least 45 minutes or so, and you saw that it was actually using less power to keep the chamber at temperature with my fume mitigation system on than it was with it off. And I think that's because once I overcame the draft here, and I was only drawing just the slightest amount of air through that vent in the back, that we're actually losing less hot air out of the printer than we are when it's able to just billow out of the purge chute. I don't know. What do you guys think down in the comments? What other explanation would it be for that? And when I came down to stop the test, we definitely stopped losing hot air here. This area had completely cooled off. Not only could I not feel hot air billowing out of there anymore, but this whole area here had cooled off. It was all cool to the touch. It was the same temperature as, you know, the rest of the printer. This was slightly warm. Like, you could definitely tell that we were drawing warm air through here, but not as warm as I expected it to be. And really only like right here. As soon as I started to work my hand up the vent hose, it was at, you know, regular just room temperature pretty quickly. So I think if you actually install this and get this balanced correctly with the paper towel trick, now you do need to increase the suction kind of enough to stop the draft, and then you can back it off and set it with the paper towel. Yeah, it's actually using less power to keep your chamber warm than without fume extraction on it. I know, crazy. So again, let me know down in the comments what you guys think. Is there another explanation that I'm missing? Is something else going on here? One other test that I did want to do that I just don't have time to do this week, unfortunately, is I'd like to do a long print with either ASA or ABS or some material that I can normally detect the smell of it, because my nose is pretty sensitive. Even on a fairly short ABS or ASA print, the moment I get even close to this room, I can smell it. So that's going to be the real test, is doing like a long ABS or ASA print to see if I can smell the fumes in this room. But other than that, I'm calling this done. I mean, I might do some additional tweaks here. A couple folks mentioned why not have a Y on this so I could hit both machines at the same time. I might do that. What I might actually do is add like a magnetic coupler here on the hose at the midpoint, so I can either have it go to a single, I could have it go to a Y and have a double, or I could disconnect it from there and maybe have like just a, you know, like sort of a fume hood intake up here that I could, you know, put the magnets over on and just run that at a very low suction all the time, so that, you know, if I'm printing on any of my machines down here, you know, the warm air that comes out of the back of the machines is naturally going to collect up top anyway, and with a small amount of suction, I'm probably clearing out those fumes from, you know, PLA or PETG anyway. Well guys, I really appreciate you taking the time to hang out with me for this week's video. Hopefully it was worthwhile, hopefully you could learn something, hopefully at least some part of it was interesting to you. And if you were going to make one of these, I'm curious to hear about it. And if you've got the ability to sort of duplicate the same test for the chamber heat and the power utilized, maybe with like a kilowatt or something like that, I'd be really curious to hear about your results in that regard as well. A special thank you to the patrons that support this channel on Patreon. And if you want to check that out yourself, I will put a link down in the description of the video to the Patreon. We've got a pretty active community on Patreon as well as on Discord. So you can check those links out on fpfdesigns.com, and that link will be down in the description of the video as well. And if this is by chance your first time here on the channel, this is all we do. It's all functional prints and the design and engineering and stuff like that that goes along with it. So if you enjoy that side of the hobby, if you want to see more of that, check out some of the other videos on the channel. And if you like what you see, hit that subscribe button. And guys, if you do, I'll see you next Friday.